Hello everyone, and welcome to today's SANS webcast, How to Build a Threat Hunting Capability in AWS, sponsored by AWS Marketplace. My name is Debbie Gruy with the SANS Institute, and I will be moderating today's webcast. Our featured speakers today are Sean McCullough, SANS instructor, Ross Warren, Specialist Solution Architect at AWS, and David Aiken, AWS Marketplace Solutions Architect. If during the webcast you have any questions for our presenters, please enter them into the questions window located on the GoToWebinar interface. We will be answering them during the Q&A session at the end of the presentation. And with that, I'd like to hand the webcast over to Sean.
Thank you very much. I'm excited to be here. I love this idea of how do we do threat hunting in a cloud environment, because sometimes when we do a threat hunting, it might look the same as what we're doing on-prem, but other times it's going to look completely different. And so just to show you how we're going to work today, this is our agenda. I'm going to talk quickly about what threat hunting is in kind of a more generic sense. And then I'm going to really dive into this idea of creating a loop where you build a process for getting better and better at threat hunting and how to inject your cloud mindset into those. And then I'm also going to talk about tools that the analysts can use in order to do that threat hunting. And then I'm going to kick it off to Ross, who's going to talk about creating a threat hunting strategy in AWS. And then David's going to follow up with enabling threat hunting through security and efficiencies in AWS. First thing I got to talk about, though, is the definition. Always got to have a definition slide. Threat hunting is really this idea that I'm going to go out and look for a behavior or an artifact or something that indicates that there's an attacker that has done something to my environment, but they've somehow evaded my security tools. So if I've got a security environment or a security tools that are monitoring all the malware that could be loaded on a machine, and so I've got anti-malware running, I'm not going to use my threat hunting time to go and find common malware, right? Because your tools are already doing that for you. They're alerting. You probably have a SOC, or depending on the size of the company, maybe it's just one person, but they're going out and they're triaging those security tools. This is trying to look beyond it. And a lot of times what that is, it's like just digging through logs, right? I mean, you're going to get logs that are going to come back that have telemetry that's describing all the stuff that's happening in your environment. And then you got to figure out how are you going to weed through all of that to try and get the answer that says, oh, there might be an attacker that's doing something weird inside of my environment. And the way we want to approach this is looking at it methodically. Like we want to try and create a process in which a threat hunter who is coming into an environment, the environment is a cloud-based environment that's going to have web applications and automated back-end environments and data stores that some of them maybe you're hosting, some of them you're having AWS manage. And you want to create a process that allows you to get better and more efficient in that threat hunting process. So the threat hunting loop has 4 steps, and I'm going to hit each one of these in detail. But you're going to create that hypothesis of what do I want to look for. You're going to start investigating with the tools and techniques and everything you've got. And then you're going to take that and you're going to discover patterns. And you're going to get better. You're going to understand more about your environment and we want to figure out how to apply that. And the last one is then informing and enriching with the analytics to try and tell the story. All right. So first one, what do I mean by creating a hypothesis? Let's assume that you've got your team of people and you're going to start threat hunting. You've got a running environment. The first question is, well, what do I look for? Like, you just don't want to start blindly going through logs because you'll probably waste a lot of time. So you got to start with something. What am I going to start as my point of looking for an intrusion? And so a lot of times when you're starting off in your threat hunting, you probably don't have a great idea what you should be looking for because you may not have a good idea of what your security services already are detecting. So that's one place to start. What do I have running? What security service do I have running? Let's assume they're doing those pretty good. What could be missed? There's a previous paper I had written called How to Protect Modern Web Apps, and it was a telecom webinar like this. And it really broke down the threat modeling process to figure out what systems you have running that are a biggest threat and how much of a threat. And so if you know that you have web applications that are facing the internet and they have their homegrown applications that you build that's maybe important to your business, that's likely a first thing you want to kind of focus on. And so you want to try and maybe use that threat modeling process I talked about in that first paper, or look at your most important products that you have running, or maybe your most vulnerable products, and say, okay, I'm going to start there. Since we're talking about web applications likely that you're building inside your cloud environment, I always say first place to stop is the OWASP Top 10. They have a really great breakout of all the different ways, well, not every different way, but most of the ways that people break in or take advantage of vulnerabilities inside of a web application. And they are very detailed in describing how it's done. They give you examples of how you can execute yourself so you can test, and then ways to detect and mitigate that. So that might be the first good place to start. I also like the MITRE ATT&CK framework, which gets a lot of people talk about it. It's really great for defenders and pen testers alike to kind of give them a visibility of, okay, what's all the kinds of things I want to do, and it categorizes it really well. MITRE just recently released a cloud-specific matrix. So looking at a cloud environment, these are the things you might want to look for, or these are the attacker techniques that attackers might use, and they've broken those down into categories. So I would recommend looking at that. Another great place is Twitter. I mean, there's a lot of researchers that are coming up with new ideas for how you might take advantage of one vulnerability or a bad process or something, and those researchers usually talk about it on Twitter, or they might have tools in GitHub. And another great place is AWS Cloud Security webpage and blog posts. They'll describe new capabilities to protect your environments, and you can use those as jump points to say, okay, what can I do to look for? So first thing you do is you got to come up with that list of few things we're going to look at. Maybe you'll focus on maybe SQL injection or attacks against your SQL environment, or attacks against your web application environment. The next thing you want to do is start investigating through tools. Now, there's a lot of ways that you can do this. You can start pulling a bunch of logs and looking at them. What I wanted to highlight was how a cloud environment might look different than you would be doing this on-prem, or it could look different, I guess to say. One thing in a cloud environment, you're trying to automate your deployments. And in order to automate deployments, you really have to have consistency in that infrastructure. So as an example, let's say you are, you've got a company, and the company has multiple web applications. You probably don't want 20 different instantiations of a web server with different patches, or some Nginx and some Apache. You probably don't want to do that. You want to try and get consistency because it makes it easier to automate. And if you have automate in that deployment, and if you have consistency in your infrastructure, it makes it easier for you as a threat hunter to hunt for stuff. So if I know that all of my web servers are Nginx of a certain patch level, and that's what they're going to look like, I can get a good idea of what processes should be running on those systems. And so when I start threat hunting and I see a really weird process on a web server that's facing the internet, I know maybe that's something I can go look at. So consistency is your friend, and it's definitely a desire in a cloud environment. So try and take advantage of that. One of the problems you're going to face is your cloud infrastructure is very elastic. So let's say you have an indicator something's wrong. Maybe one of your EC2s suddenly has a spike in memory or spike in CPU usage on a Friday, and somebody makes a note of it. Come Monday, when you roll into the office and it's time to look at it, that system's gone. Like, it's been shut down, it's been replaced, and you might not have the logs you need to determine, is it just the application was acting crazy, or was there a Bitcoin miner that had been installed on that system? So you need to kind of think through, what is the data I need to collect, and make sure that you're collecting enough of it so that if you're coming in a day later after a potential event, you have the data you need to reconstruct what happened on that system. And if not, you're going to have to go back to your infrastructure team or maybe your dev team and say, we need more logs, and we need them looking like this. May not need them for months, but certainly for a week. The other thing you could take advantage of is this idea that in a cloud environment, it's likely, since you're trying to automate your deployment, you're probably automating a lot of your processes too. And you can look for things in a pure cloud environment where you have an organization that has done some kind of infrastructure as a service, infrastructure as code, where you're deploying all your infrastructure from CloudFormation or what have you, a human operating that environment can look very different than the machine, and maybe you can take advantage of that. So for instance, in Amazon, every API call that is made can get funneled to something called CloudTrail, and we're going to talk more about these individual tools. In CloudTrail, you could have an application running on an EC2, and that application's job is to go pull data from an S3 bucket, let's say. Very, very standard thing to happen. Because it's an automated application and not a human, that application always knows which bucket to go to. That's just kind of built into the code. If there's a human that has gotten access to that EC2, and you're afraid that that may be an attacker, one of the first things they might do is actually just list all the buckets. Like, what are all the buckets that are out there? Or what's all the data inside a particular bucket? These are things that in a production environment may not normally happen. And you can start looking for those weird human potential actions. And you can query the data, the AWS infrastructure itself to ask those questions. So I have up here in this diagram, in the page here, you can see the CloudTrail GUI where you can ask some simple questions about getting back API information. In this particular case, I asked for list buckets. But below, you can see you can make a simple query. And that query can interrogate the APIs, bring back all the logs that have a particular event. And then, because it's JSON, you can manipulate it a different way. So you can look for things that maybe in a home-built environment or an environment that builds all the time will look very different than in an environment that's a cloud environment that you're trying to automate your deployment. All right. The next thing you want to do is try to uncover patterns. And if you look at online, if you look at a lot of discussions about the loop here for threat hunting, there's a lot of conversation about, oh, I see a pattern of bad activity, now I'm going to go and pursue it. And definitely you want to do that. But as a threat hunter, you're also going to see patterns of how your operations of your team, of your applications work that most of people will not see. Your developer are not going to see this data. The people who are basically monitoring the SOC or running the infrastructure won't see this because they're not diving into the logs. And you might find that there is parts of your infrastructure that maybe doesn't have enough logs or is operating a little weird. Maybe you have systems that crash quite often. And that can cause you as a threat hunter to go down these rabbit holes to find it's just a misconfigured application. Go back to your infrastructure teams, but go back to your product team. Say, hey, we're seeing this pattern a lot. It looks very weird, but it's usually benign. Can we fix this? And if you can fix that, you can make your threat hunting easier. Or maybe I wouldn't say easier, but certainly clearer. So maybe you don't go down those rabbit holes quite as often. And you can get a clearer picture of what's normal in your environment versus what would be an abnormal activity, would be a threat hunter. So take those patterns and make use of it. Last part is informing with data. You get a whole bunch of logs back, and those logs are going to tell you just all kinds of stuff. And if you look at each log individually, you're probably not going to get the whole story. So you got to think about how much data do I need? Remember, and you're in a cloud environment, you're paying for the data that you store. So you don't want to keep all the data from all the things forever. That would probably be unnecessary. But you could definitely pull back your logs from applications or from hosts or from the API calls that are happening through CloudTrail. And you might start identifying information that is missing, stuff that you're not collecting, maybe about your environment or specifically about your the code that's running itself. That's another big one. So if you have applications running on an EC2, and then that EC2, you have data that maybe is missing that you really need, such as failures or restarts, or if you are running an Nginx server maybe. And you can see if you have the Amazon WAF running, you could probably track that there's SQL injection attacks, right? So if you have those SQL injection attacks and you suddenly see that there's for an hour, there's constant SQL injection attacks, and then they stop. Well, that's great. I can see that through the logs that are collected. But why did they stop? Did they stop because they just gave up, or did they stop because they're successful? Well, the next thing you probably want to be able to do is dive into this application itself and say, all right, do I see a process running on that system that's not supposed to be running? Or did I see data leaving that I wasn't supposed to be leaving? So you might have one picture and you might need to add to it with other by identifying missing information, going back to either the people who are running the systems or the developers and trying to get that data and match them together. And you can use that data to maybe enrich. So if you have a whole bunch of logs about an EC2 and all the EC2s just have like a serial name I dash something, 1, 2, 3, 4, 5, that doesn't tell you anything. So maybe you need to start tagging the data before it comes back. Maybe you should always know that I have put tags in your EC2s to say which business unit they belong to. That way when you start investigating, you know immediately that this is a forward-facing web server versus maybe an internal test one. And then you're going to want to try and build tools or maybe buy tools that's going to improve your analysis and speed. And so we'll talk about that more detail in this talk. One thing I mentioned was Nginx. You have this ability to grab logs that are being created on the host themselves through something called CloudWatch agent. And that CloudWatch agent is really just an agent. Just sits there and monitors a particular log. In this case, I'm showing that the /var/log/nginx logs, which describes all the connection information. And every time somebody submits a request to this proxy, it's going to capture that. You can take all those logs and push them to CloudWatch. And from that, you can create metrics, but you can also use that to run some simple queries against that. So in this particular case, I said, hey, if I have somebody that's doing looking up /password and maybe some other things that would look like it's a URL traversal attack, I can run quick queries against the data that I'm collecting to see, do I have actual activity happening on this host that maybe it's not supposed to be there. And these are tools that are provided for you directly by Amazon. And the CloudWatch service will not only show this kind of data, but allows you to create alarms, metrics, dashboards. So as you start saying, hey, I want to look at data over time, or I want to be able to monitor CPU usage or connections or anything like that, you'll be able to build those things pretty quickly in CloudWatch. So that leads us into this idea that you can do some quick analysis inside the cloud environment, but then you can also may have to bring something a little beefier, like a SIEM, to your environment. And I'll talk a little bit about that. And then the cool thing is maybe you can say, hey, not just get data and have a human look at it, but can I automate a response? All right, quick analysis. So I mentioned these, and so I don't want to go too much into them, but that AWS CloudTrail can provide full logs of all your API calls, and does give you a pretty quick interface for them. You can also push those to an S3 bucket, and you can do even more analysis on them. But those are all the API calls. So it's a ton of stuff. It's a lot of stuff you may not want to keep very long. You're probably not going to look at all of it. But as I showed earlier, you might be able to use that to see, is there an activity on a host that should not be happening on that host? Do I have somebody on an EC2 that's trying to look for all the S3 buckets in my environment? That's not something that normally would happen. You could quickly use CloudTrail to do that. I mentioned CloudWatch in the previous pages. That has dashboarding and alerting. And when I say alerting, you can push things to a screen. You can have them email you. You can do a Jira ticket. I'm sure you can even have a Slack message. So these are all push outs that you can use in addition to dashboards that display stuff. One nice thing I'd say about CloudWatch that I really enjoy is that if you're using CloudFormation to automate your build process for your applications, you can automatically build dashboards for that too. So if you are deploying your 20 web servers, you can also deploy CloudWatch dashboards to show an alert on things that may want to alert. But next thing you want to do is try and maybe do some more advanced stuff. And Amazon Athena is really cool. This allows you to do much better ad hoc querying against S3 databases. And so I just got a screenshot to show you here. But if you have an S3 database, or I'm sorry, S3 bucket, and that S3 bucket has a bunch of log data, and that log data has some kind of structure to it, you can say, hey, here's my structure, and you can use that to create what's called a virtual table. And then you could build and run and execute queries, SQL queries. I mean, you look at that, it's very much a SQL query to try and gather even better data than maybe you could with the other tool sets. And you can start funneling a lot of logs to this Athena service and start building some better ad hoc tooling. So as a threat hunter, if you suddenly have this hypothesis that, oh, I need to look for this type of attack technique, here's the data in which I have in order to detect that, I can go and write this SQL query to try and pull out some indicators that this is actually happening in my environment. These tools are really great if you have a lot of data, or maybe you need to bring your on-prem data into it. You might want to go out and get a SIM that's going to provide much easier integration of different kinds of logs. Like most SIMs already know how to ingest Nginx logs, and also they'll have adapters to be able to ingest the cloud logs. So all those AWS logs in the CloudTrail, things that you're bringing in CloudWatch, Maven S3, you can push them all into this SIM. And you can also bring your on-prem data into the same SIM. So there's a bunch of SIMs out there that are able to do this. There's a few of them that are very easy to just install inside your AWS environment. And so if you like one that's pretty big, you probably can bring that to the cloud with you. What I'm really excited about is this idea of SOAR. Can I automatically, let me step back. You have this SIM, you have all of this data, you have these threat analysts, they're figuring out what's the bad stuff. Well, after a while, you're going to say, okay, every time I see this bad activity, I want to go and do something, all right? And maybe that do something is pull more logs. So let's take this example that I have a lot of SQL injection attacks, and then suddenly it disappears. Well, maybe I could have this SOAR system, which is already collecting all this, use this thing called a playbook, is usually what they're called. And a playbook says, if I see a whole bunch of SQL injection attacks, and then suddenly it stops, immediately query the host and bring back a process log. Query SSM or some kind of host agent, OS query, whatever it is. Grab the processes that are running on that host and look to see if there's something that's not supposed to be there. You can automate gathering more data for your analyst. You might be able to automate something if you have an EC2 and you have, say, hey, there's a bunch of SQL injection attacks, and it just seems like it's a lot. Maybe over an hour, it's just a ton of attacks. You could have SOAR automatically take a snapshot of that host, quarantine the host, get the host out of the environment, spin up a new one, and just have it sit there so that maybe that's on a Friday. On Monday, when your threat team comes in, you have preserved all of that host so you can go and look at it. Or if you know that there's an activity maybe from guard duty or some other kind of service, you could automate things like revoking user access keys or some other kind of remediation where you're stopping a service or stopping a person from gaining access. I love this idea of SOARs. I see this as services are being built inside the SIMs and other products to do more of this, and I definitely think this is where threat hunting can get better, because you can use these SOARs to go and enrich your data, grab missing data, and be able to pull the data you need from individual hosts, but only at the time you really need it. All right, so just some things to consider. Your threat hunting process is going to be continuous. You're always going to be learning. It's never going to stop, hopefully. And you need to start off with a solid starting point. Create that modeling process. Figure out what's my important things and how vulnerable are those important things, and dive into those problems first. I do recommend starting with the free tools that the services provide you, easy scripts. You're not going to be able to look at a ton of things at once, but you're going to get a really good idea of what are your logs, what do they really look like, how is the environment actually operating, and as you get better and more knowledgeable, you can move to the bigger products that allow you to do those things at speed. And the last thing I want to leave you with is that threat hunting in a cloud-specific environment is rapidly changing. The cloud environments are changing, new tools are coming out, and so being able to hunt inside those environments is constantly changing. So you're always going to be researching new ways. You're never going to stop learning about a new technique or potential of vulnerability, and your environment is never going to change. So you're always going to have to be able to adapt. And so this is a great way in which to always be learning, always be trying new things, and to always get better at your threat hunting. And with that, I'm going to turn it over to Ross, who's going to talk about creating a threat hunting strategy in AWS.
Hey, Sean, thank you very much for looking at threat hunting and some of the tools and use cases that we can actually enable on AWS. There's going to be a bunch of overlap. Sean and I are of the same mindset. And you'll see a lot of the same themes as we go through and talk here the next couple of minutes. Today I'm really going to give you a foundation on, slides, on how you can start building a threat hunting strategy and a plan. Before we step into that, however, we need to remember that in order to embark on threat hunting, you really must start thinking about and creating a solid foundation through an efficient security operations center. As we start thinking about that, this data that Sean was talking about, CloudTrail, DNS, CloudWatch, all this data has to be collected, organized, and contextualized before it can actually be analyzed. Some of the services in AWS that help us with that are, AWS Security Hub, CloudWatch, as we talked about. Some other options, you can actually combine threat intel with this contextualized data and feed it into SIM like Sean was talking about, and that's going to help us maybe discover some new threats or any threats we're looking for. And as Sean was kind of finishing up there, finally you can move then on to orchestration, automation, and response. Creating this well-oiled machine will not just bring out the efficiency in your SOC, but it's also going to provide an environment so you can allow your analysts to start doing proactive threat hunting. Now that we've got this well-oiled machine running, or we're starting to think about that, resources, as I said, can be freed up to threat hunt, creating a proactive environment versus a reactive security program. This is really key. Reactive versus proactive is showing us that our SOC is actually maturing. But where do you start? You need a goal, of course. Threat hunting is a journey, so that goal should be long-term and never-ending, like Sean was talking about, and it's going to take some time to get there. One can think about hunting either, fully manual, the full left side of this, or on the other end of the spectrum, fully automated. I don't believe that full, complete automation exists yet. We still need a human in the loop, and so we can maybe strive for the sweet spot a couple steps before that full automation. It's pretty hard for an adversary to actually do simple tasks in your environment without leaving behind fingerprints. Those bad actors' digital fingerprints are usually there somewhere. You've just got to know where to find them. Above are some of the sources that Sean was talking about where you can actually start that search. They include everything from host level logs to CVE findings from Amazon Inspector to VPC flow logs, and even full packet capture from the new VPC traffic mirroring service. Sean had some examples of CloudTrail, but I wanted to bring up just another one showing you the level of detail you can actually get from a single CloudTrail log. Not just the API calls, but you're getting time, account ID, source IP address. All this great rich information is what you're going to need to actually do that hunt. To do hunting well, I think hopefully you're getting the story, you're going to need a lot of data. We'll talk more and more about that data a little bit later, but for right now, you just understand that every single one of your computers and network devices is likely generating 24 hours a day, 7 days a week. And the more you have available, the more you're going to be able to uncover. I like to think about this data in 3 different domains: network, host, and application. I think everybody kind of understands that, but in the cloud, that blend is, a little bit a gray area. So network data really refers to the things that are actually transmitted over the wire. Although it can include full packet capture, it's typically more, observable events on the network, like network sessions, HTTP transactions, file transfers. This is probably the richest of those 3 data domains in the variety of information that you can just gather and the value you get from all this information. After all, everything actually is hooked up to the network and doing transactions on the network. Host data. This relates to events that occur on the computer's environment. It could be users logging on and off, records of processes that start and stop, logs of what files are accessed, or basically anything else that happens on a host. And finally, application logs or application data. This is events logged by the programs running in your environment. Could be database logs, database transactions, audit or transaction logs from a customer portal. But I also like to put security alerts and endpoint security logs into this category. although most of them are generated from activity that occurs in either the host or the network domains. One thing to note here, if you're an eagle eye, you'll note that I've included authentication as the first item under each domain. If I could keep just one type of log, it'd probably be authentication. Who's using my computers? Who's logging into my applications? Even just knowing who logged in and when can be very helpful when you're trying to spot that malicious behavior. As you can probably imagine, taking together all this data across these 3 domains adds up to a lot of data, especially when you consider you may need to store a lot of this data for weeks or even months or potentially even longer. A common question is, how much data should I be storing? For hunting, the more data the better, but only up to a point. Don't make it overly complicated at first, and we'll talk about that more in just a minute. As you probably can guess, some of this data, or most of this data, is actually linked to other pieces of data, right? That IP address is a link that ties a web browsing activity to user account names where they're logged on, but it really only matters if I've got some of those tools that Sean was talking about that can help me pivot easily between or from one data source to another. And that's really the important part of hunting. Pivoting like this can help you reveal those hidden relationships between events that may seem unrelated, or it can actually help clarify the nature of relationships you already know exists. Let me dive into that a little bit. A good use of that pivoting is to see if multiple data sources agree on what's happening. You know, just like a police detective in all our police shows, interview several witnesses separately to see if their stories match. Pivoting through different types of logs can actually see if they support each other, and sometimes actually can help you spot inconsistencies, you know, maybe where the attackers are trying to hide their tracks. A good side effect of this, or pivoting through these multiple data sets or data sources, it also helps you discover and tell the complete story of what happened, not just with that one event, but with all the other events that led up to it. Threat hunting is not necessarily just a point in time what happened. You know, if you're using the kill chain model, for example, you would probably like to know and discover what happened before this event or this finding, and maybe what happened after the event, so that we know how deep the attacker's in, how what depth and breadth they're actually inside my network or inside my instances. The building blocks for a threat hunting program. There's no substitute for human knowledge and intuition. I think you're hearing that from both Sean and I. You know, there's no substitute. We need those humans actually inside the loop. It's not to say that computers are all bad. Research shows that when a problem has many variables, or when feedback about a decision is delayed or hidden, a good algorithm can actually outperform a person. So you achieve your best results when you use both people and algorithms in this process. A human who directs that investigation using familiar, trusted algorithms, those playbooks that Sean was talking about, can produce very good results from a mountain of data in a reasonable amount of time. It all comes back to this. The building blocks for that successful threat hunting program include a mix of people, technology, and processes. So as a hunter, you don't just sit down in front of a pile of data every day and you do your thing without prior thought. You would go crazy staring at mountains of data, all these different log sources. You may be able to get by with this when you're just starting and trying things out to see what hunting might be like, but a good strategy is essential if you want to move beyond just that experimental phase of hunting. That strategy that you're thinking about helps you focus all aspects of your hunting on the goals that you're trying to achieve. It helps answer key questions like, where do I even start looking? Or what activities are most critical for me to discover right now? Or maybe even more importantly, a good strategy has a built-in path for improvement, making it easier to answer questions like, what comes next? And how should my hunting capability evolve over time? Some of you may have seen this before, some maybe this is brand new, but with that, the initial strategy of hunting in mind, you might be asking, what makes a good hunting program? Based on experiences running hunting programs and talking to others who are doing the same thing in their own companies, a mentor of mine, David Bianco, created the hunting maturity model as a way of documenting the typical types of programs that are out there and how they tend to progress and improve over time. And there's really three factors to consider when judging your organizations or where you actually sit in this hunting maturity model. The quality of the data you're collecting for hunting, the tools that you're providing your hunters to access and analyze that data, and the skills of the analysts who are actually using the data and the tools to find these incidents. And I think of these factors, the analyst skills are probably the most important, since it would allow them to turn that data into detections. So the hunting maturity model describes 5 different levels of organizational hunting, ranging from 0, the least capability, up to level 4, the most. Level 0 is essentially no capability at all, very little collection of data beyond simple alerts that we're getting out of an IDS, a DLP, an AV system, or whatever. The entire detection program is completely reactive. You're reacting to alerts. You're spending time, 100% of your time, just processing the alerts as they come in. As you move up that, the first level is where some actual hunting occurs. Organizations at this level focus their efforts on searching their environment, typically for indicators of compromise or IOCs, and they're receiving those from threat intel feeds or some, other threat report providers. Because the motivation at this level is search, they usually have a moderate to a high level of data collection. You see that they're maturing in their data collection procedures. They're probably focused on the transactions, the network connections that are going across the internet boundary, since this is the type of threat intel that's most prevalent in the market. Although they may be collecting some east-west traffic, traffic that's going on inside their network, or even some logs or threat intel on their hosts. Even though you might consider level 1 to be real threat hunting, when most orgs say that they're hunting, they really mean level 2. At this level, an organization is able to follow data procedures, analyst procedures, published by others. So if you Google, there's a lot, as Sean mentions, there's a lot of actually procedures out there for hunting. And at level 2, you're taking those published procedures, you're using your own data, and then interpreting the results to find the bad guys in your network. Level 2 is kind of that sweet spot for hunting, in that you can get very good results by following those published procedures without really needing advanced analytical expertise on staff. As you move up, level 3 hunt team, they have at least a few hunters that understand data analytics really well, and they're able to create new procedures, essentially creating their own hunts. And generally, in fact, level 3 hunters are actually the guys and gals who are publishing the procedures that the level 2 folks are actually following. Their analytic skills may be as simple as just basic statistics, or more advanced stuff like linked data analysts or data visualizations, or even some machine learning. The important point at level 3 is that the analysts are able to apply various techniques that they are familiar with and various combinations to create repeatable hunt procedures. Finally, level 4. The level 4 team is just like any level 3 team with one really important difference: automation. Sean talked about sort of those SOAR procedures, those SOAR playbooks that in the last part of his slides. A level 2 or level 3 team actually wastes a lot of time repeating the same hunts over and over again on some regular schedule. Even if procedure is straightforward and easy to understand, it just takes time to search and filter for those exact results in the data you need. The key difference here between level 3 and 4 is that automate when possible. As I said, hunting is not full automation, but we're automating when possible, when it makes sense. Those level 4 guys really use their hunting program not only to find the bad guys, but really to improve the effectiveness of their automated detection and their hunt program overall. If you want more information, take a look at that URL that's on the screen. You can dive a lot deeper than I am doing now. One strategy: extracting value from that existing data. Look around and see what you already have. This method has a lot to recommend. Data collection can be tricky and laborious, so take advantage of what makes sense, what you're actually collecting now. Sean talked about, we've got some great data sources in AWS. Hopefully someone who's already using it they may be actually be able to help you get up to speed quickly on the data, what it contains, what's important. Talk to the folks running the services at your company that are spitting out those logs. They know where they are, and they actually know what is actually important. Using existing data tends to have a much lower effort of barrier to entry. Collection is tricky and does take a lot of time and effort. Because AWS is already providing CloudTrail and CloudWatch, you know, this means you may be able to show them results more quickly by actually being in the cloud. We're going to skip forward a little bit. As Sean talked about, and as I started this off with, remember, hunting is a journey, not necessarily a destination. We've spent some time talking about the details of a hunting maturity model, but how does this help you understand when you're just thinking about getting started? That is, you don't just do hunting one day and automatically start to be the best around. Think about the hunting maturity model as a continuum. It's a map, and you can start hunting anywhere on it. Probably the first thing you want to do is go back to that URL and assess where you sit, where your own organization's ability and capabilities are, and paste a big old "you are here" on it. Whether you know or not, you already have achieved at least one of those levels, even if it's level 0. Continue to move up that path, move up the journey, you know, see what the next steps are for that next level, get to that next level, and then repeat the entire process and keep going until you get to a comfortable stage. For the most organizations who don't already consider themselves hunters, that level 2 is a pretty good first goal. Remember, don't rush. Celebrate your successes along the way. Take a break if you need to, and take a good look at that hunting maturity model. Now that we discussed how to create a threat hunting strategy and plan, I'm going to pass this webinar to a colleague of mine from AWS Marketplace, David Aiken. He's going to discuss some of the marketplace solutions around threat hunting and SIEM.
Awesome. Thanks, Ross and Sean. So what I want to do is just start off by showing you some of the solutions that can come together to help you increase efficiency in whatever security operations that you're actually doing there. As both Sean and Ross mentioned, you've got a huge amount of data points to be able to collect, and a lot of rich data sources. How do you kind of handle all of those, and how do you bring them all together is something that we hear quite a lot from customers. So I want to start off just mentioning real quick AWS Security Hub, which allows you to bring all of these different data sources together, but then actually fire off CloudWatch events to potentially do some automation around it. So if you look on the left-hand side, we've got different potential data sources from firewalls, from endpoint protection, compliance reporting, and that kind of thing. And on the right-hand side, we've got some tools that can help take action on those events. So this is really kind of building up, going to help you build up that knowledge of an automation around handling some of the basic things that come along there. SIEM and SOAR solutions, I think Sean mentioned, can help you really focus on threat hunting by increasing your efficiency, right? A lot of these tools allow you to kind of build queries and identify potential threats through that, and then fire off automation. And one of the key kind of tricks from customers who are successful in this is how much you're able to automate at least some of the first response aspects of a breach or an issue. Great way to do this is to make sure you're creating consistent workflows with guardrails to make sure you are capturing all of those playbooks, and automation is the key there. Humans are great, but humans make mistakes, and sometimes, you know, Friday night, the person in the SOC forgets a step or doesn't carry out and just terminates the instance. You're going to lose a lot of intelligence by doing that. So some automation around that's really going to help you do that. Now, one of the SIM products that we have on there is Sumo Logic. So I want to talk a little bit about Sumo Logic and how some customers are using this. Now, Sumo Logic's the SIM. The key benefit we see customers using Sumo Logic is actually reducing the time to investigate security and operational issues, so they can actually free up time for further threat hunting. One of the challenges, as we've talked about, is how do you handle the sheer volume of log data that potentially is generated each day? Some cases we've seen customers into the terabytes of log data, and it's not only volume; it's also different sources can grow as well. So Sumo Logic is a SaaS-based service. It can process huge amounts, petabytes of data, handles 20+ million queries a day. Elastic solutions, so they're built on AWS, so they're going to take advantage of all of the great elasticity that AWS offers. But what it's helping customers do is take those thousands of log lines and try and understand some of the patterns by reducing those down into just a couple of lines. And they have a couple of tools in there called log reduce, log compare, which actually do a lot of that for you. So again, huge amount of data. What is the signal from the noise? And Sumo Logic can kind of help you get down to that. Now, as we mentioned, we've got all these different log sources, CloudTrail, VPC, flow logs, and so on. Sumo Logic's going to ingest that as well as logs from application sources, and it has integrations with all of your favorite tool sets. There's some 150 application integrations that it has. But one of the real cool things from Sumo Logic is they have a global intelligence service for Amazon Guard Duty. And to kind of summarize this a little bit, what they do is they're able to take the logs across multiple customers that's been emitted from things like Guard Duty and other sources, and figure out attacks based on multiple customers. So, if you think about your environment, it's probably quite straightforward. I wouldn't say easy, but straightforward to figure out the top 10 attacks on your account, right? We've mentioned sources and playbooks and procedures to do that. But one of the things you're going to miss there is attacks where the pattern only appears when you can analyze across multiple customers' data and look for patterns basically across multiple environments. And this is what the Sumo Logic tool can do. Another adopter of this service was ThoughtWorks, who are an open source app company. They do some consultancy as well. And one of the biggest values they had was just giving them actionable insights to help prioritize and look for rare or non-frequent security events from their workloads. So, it's great if you spend, if you see that hour-long SQL injection attack trying to brute force its way in, but what's some of the subtle things that maybe are going on that you don't, that aren't easy to kind of pick out there. So, has to be probably one of my favorite companies to talk about, Pokemon. Pokemon company actually looks after the brand for Pokemon across video games, mobile, TV shows, wherever like that. Obviously, working with a lot of IP, targeting children, so security, privacy concerns all are a top priority for Pokemon. And one of the challenges that they had was giving their security team visibility into what was going on within the environment. And what Pokemon were able to do is take the Sumo Logic machine data analytics service, it's a mouthful, and basically it was able to crunch through all of these logs and actually start giving them some insights into where to go look and where to go do their threat hunting and what problems to go address there. So what it was, what basically enabled the security team is go from hundreds of hours looking through multiple log sources trying to do this correlation to being able to do it in a few minutes and actually get some insights and be able to respond. And in terms of responding, they look for a SOAR solution to kind of help automate and implement some of these playbooks and runbooks to correct things. So as an example here, they're using Demisto from this, which is from Palo Alto, and one of the scenarios could be we're finding we're getting a bunch of attacks from a particular set of IP addresses. The SOAR can kick in from that information and actually fire off some events to go block up the whole. And in this case, what they're doing is they're updating the rules in Palo Alto firewall, which we're using as well, to actually automatically lock out IP addresses based upon the actual activity that they were observing through there. So again, as both Sean and Ross mentioned, being able to automate some of the responses here is going to free up your team's time to actually dig into things. So you're probably wondering, like, hey, you talked about a couple of vendors here, but why would I go get these through Marketplace? Well, Marketplace is a great place to actually go find some of these products and services that we talked about today. But there's a ton more security tools and services within Marketplace. And you'll appreciate going to AWS gives you a lot of flexibility in terms of deployment models, but also elasticity in terms of being able to spin up infrastructure when you need it and switch it off when you don't. So Marketplace actually gives you pricing based around being elastic. So if you're deploying, say, a firewall solution, or maybe you're deploying one of these solutions we've talked about, you can scale up and scale down and only pay for the software licenses when you scale up. So, if you have 4 instances running, you're going to pay for 4 instances. There's no need to over-provision your software licenses, which gives you a huge amount of flexibility. The other cool thing about Marketplace is, as you probably realize, we have a team of SAs, most of who are way smarter than I am, to kind of help you. So if you do need some guidance around products and that kind of thing, we can get you in touch with one of the SAs there. So how do you get started? Well, do check out Marketplace. There's a ton of tools on there that you can quickly deploy into your own AWS accounts, and spend a couple of dollars, $200 to get going. Many of the tools actually have free trials. So in terms of software licenses for some of these, you're only going to be paying the infrastructure costs to run that. And the cool trick is to go create a new AWS account and get that free tier. You can actually do some pretty good POCs, and it's going to cost you a handful of dollars to be able to do that. As I mentioned, buying, we've got a ton of different ways you can buy, everything from bring your own license to pay-as-you-go, which is consumption-based billing. We also have the ability to do private offers. So if you want to go buy Sumo Logic and roll it out across your entire fleet, you can work with Sumo Logic and negotiate both terms and price and actually transact that through Marketplace as well. And we also offer the ability for channel partners to do that as well. And then finally, we've got SaaS deployments, things like Sumo Logic, Demisto. We've got AMIs, which things like Trend Micro, Barracuda firewalls, that kind of thing. And we also have ECS or container-based deployments as well. So if you're looking at rolling out container applications into production, do check out some of the tools and in particular some of the security tools around containers there as well.